The Thursday Thought Experiment, Episode 9, The Chinese Room. A tempting way to think about the human mind is to treat it as a kind of computer. On this view, consciousness is not magic, but computation running on an unusual substrate. Brains are wet, messy, and massively parallel, but perhaps, at the right level of description, they implement complex algorithms over representations. If so, then in principle, a suitably programmed machine could have the same mental states that we do. A substrate would matter only insofar as it supports the right patterns of information processing. John Searle's famous Chinese room thought experiment presses hard against this picture. Here is the thought experiment. Imagine an English speaker who knows no Chinese locked in a room. The room contains a rule book written in English that maps Chinese input symbols to Chinese output symbols. Slips of Chinese characters arrive through a slot. The person in the room consults the manual, manipulates the symbols according to the rules, and returns the corresponding characters back outside of the room. From the outside, it appears that the room understands Chinese. The outputs are coherent, even indistinguishable from those of a fluent speaker. Yet inside, the person has no grasp of the meaning. They follow syntactic rules without semantic understanding. Searle infers that computation, formal symbol manipulation, by itself is not sufficient for understanding or consciousness. A simulation of a mind, like a simulation of a rainstorm, is not the thing itself. Several responses aim to diffuse the argument without denying the force of Searle's intuition that the person alone does not understand Chinese. The systems reply, it is not the individual following rules who understands, but the whole system, consisting of the person, the rulebook and the room. Understanding may be an emergent property of the organised components. This can be countered with the idea that even if the person internalised the rulebook, memorising all of those mappings, they still would not understand. They would merely be manipulating the same program in their head. We also have the robot reply. Understanding requires coupling to the world. A purely text-in, text-out system is disembodied. Embed the program in a robot with sensors and effectors, allowing it to learn the meaning of words through interaction, and the gap between syntax and semantics might just close. A response to this is that embodiment adds more inputs and outputs, but remains computational in character, and thus does not secure genuine understanding. We also have the brain simulator reply. What if the program does not merely manipulate abstract symbols, but emulates the causal structure of a Chinese speaker's brain at the level of neurons or even molecules? If every relevant causal pattern is captured, why would understanding be absent? To this we might respond that what produces consciousness are the biological causal powers of actual brains. A perfect simulation has the right formal structure, but lacks the right physical basis, just as a simulated fire does not in fact burn. We may also consider the complexity reply to the Chinese room. The idea here is that the Chinese room is drastically oversimplified compared with the brain's billions of neurons and rich dynamics. Perhaps understanding arises only at a certain scale and organisation that this thought experiment simply ignores. However, in reply, we might note that adding complexity to a purely syntactic system does not obviously seem to conjure semantics and meaning. It merely magnifies the same kind of processing. And we might also consider an eliminativist reply. We might argue that understanding and consciousness are folk psychological constructs that will be replaced by proper scientific accounts. And if there is no such inner property to be missing, the puzzle simply dissolves. However, some find this too revisionary, since our sense of understanding seems central to our mental lives. But beyond these dialectical moves, deeper questions arise. First, what would count as evidence of understanding? Turing suggested that indistinguishable performance in conversation suffices pragmatically. Searle insists on a further inner fact. If behavioural criteria are rejected, we need a principled, observable marker of semantics that does not reduce to behaviour or computation. That is a difficult standard to meet. Second, what, if anything, bridges syntax to semantics? Some proposals appeal to learning and use. Meaning is thereby constituted by how representations are acquired, updated, and deployed in context. Others emphasise embodiment and enaction. Meaning is grounded in sensorimotor engagement with the world. There are many frameworks available, and each suggests that particular organisational features, not bare symbolic shuffling, really matter. If computation is broadened to include these causal, dynamical, and embodied properties, Searle's target may be narrower than many contemporary computational theories. Whatever the details of our preferred response, the Chinese room highlights a distinction between following rules and grasping meaning. But human understanding itself unfolds through rule-like processes at multiple levels. We learn, generalise, and correct our inferences from feedback. The line between mere rule-following and genuine understanding may be less sharp than the thought experiment suggests, especially if understanding is not a single property, but a family of capacities: interpretation, explanation, transfer to new contexts, self-monitoring and grounding in the world. Perhaps the safest conclusion is modest. Computation as mere formal symbol manipulation seems insufficient, but computation as richly embodied, learning-driven, causally integrated organisation might be necessary and close to sufficient. Whether consciousness requires something over and above even that, some irreducibly biological ingredient, remains an open and interesting question for philosophy and cognitive science alike. In closing, a question for you all to ponder. If you encountered a system that could learn your language from scratch through real-world interaction, explain new concepts back to you, and revise itself when it was wrong, what further evidence would you demand before saying that it understands?